Hello everybody, my name is Aniat and today I'll be covering the problem number 2, implement DFS. In this problem, we need to implement a helper function for DFS, which is called explore. And explore takes in adjacency, a list representation of the graph G, a starting vertex V, and a visited array indicating which nodes have been visited already and which have not. Explore then does a DFS traversal of the given node and returns a new visited array to indicate which nodes Explore traversed and which it did not. Essentially, Explore runs DFS starting only from one vertex and returns an array of what is reachable from that vertex and what is not. So we're also given a graph consisting of values 0, 1, 2, 3, 4, 5, and 6. And below, you can see its adjacency list representation. So I believe that first we need to learn how to create an adjacency list for any graph, and only then try to fill in the blanks. So imagine that we have this graph consisting of values 0, 1, 2, and 3. And by values here, I mean, of course, nodes. Below, you can see its adjacency list. So how did I create it? So at each index, and the first index is of course 0, I have the values of the nodes that are reachable from it. So let's look at the node 0 first. The first node that is reachable from it is 1, and the second node that is reachable from it is 3. Therefore, I put the values 1 and 3. The next index is 1. So let's look at our edge, I meant vertex 1. And it has 3 edges from it. And the first one goes to the value 0, the second one goes to the value 2, and the last one goes to the value 3. So I put those values in its adjacency list. The same I do for 2 and 3. Now we're ready to run explore on it starting from 0. So we know that by running explore on the graph above, we need to, our end goal is to return the vertex that are reachable from the vertex 0. So since every value is reachable from 0, we need to return an array that has 4 truths. Again, because all of the vertices 1, 2, 3, and 0 are reachable from 0. And of course, if there was a new value, let's say 4, we would say that 4 is not reachable, and at index 4 in our visit array, we would have the value false. But yeah, let's deal with an easier condition first. I will create a visit array which has the values false, 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 and false. So 4 false values because we have 4 nodes. And the first call, first explore, would be with v equal to 0. Because again, I want to show what would happen if we run explore starting from 0. The first step would be to change visited 0 to true. So let me do it actually in blue color. Next step is to iterate through its adjacency list. So let's look at the adjacency list of 0. 0 can reach the nodes 1 and 3. Therefore, we need to call explore on 1. Let's do just that. So explore on v equal to 1. Now we're going to do the same process and change 1 to true in our visited array. And then we would iterate through the adjacency list of 1. Therefore, we would look here. and it can reach 3 nodes. The first one is 0, but it's very crucial to notice that we already visited 0, and therefore we need to ignore it. Why? Because otherwise we would be just jumping from 0 to 1 and from 1 to 0, and this process would run indefinitely. Therefore, we need to ignore 0 and go to the value 2. 2 has not been visited yet, therefore it's safe to visit. So the third call to explore will be with v equal to 2. We would mark 2 as visited in our array. And lastly, we would also traverse through the adjacency list of 2, and we would see 1, which has already been visited, and 3, which is not visited yet. Therefore, we would call explore on it. It's our v equal to 3. And at this point, we need to return our visit array because every value that is reachable from 0 is already has been found. So yeah, return visited. And if you need to remind yourself the order of visitation, it was 0, 1, 2, and 3. Now we are ready to fill in the blanks in Implement DFS. So at each step, we change it, our visited v to true. Next, we traversed through the adjacency list to check if there is any vertex that we can go to. So we can do that by creating an I equal to 0, I less than gv dot length, I plus plus. So gv here returns the adjacency array of v, and by calling length, we are essentially iterating through the values that are in its adjacency list. For example, for v equal to 1, v would return this array of consisting of values 0, 2, and 3. And yeah, I would iterate from 0 to 2. Next, we need to check if the value has already been visited. So how do we do that? First of all, we need to see what is GVI equal to. So GV, again, is going to return this adjacency array, and I would be essentially those values, 0, 2, and 3. So by calling visited GVI, we can check if this node has already been visited. So we need to traverse through this node. If visited, GVI returns false, because therefore this node has yet to be visited. So if we put not in front of it, our false value would be equal to true, and our if condition will trigger. And if you remember, if the node has not been visited yet, we need to call explore on it. So we are going to do so by saying that a visited is equal to explore G visited and I GVI. I meant. Okay. And lastly, of course, we need to return visited. I believe that it is a very interesting algorithm and one of the most beautiful ways to return the every vertex reachable from the current vertex. Thank you for solving this problem with me.